Students, our lab 24 EC 202L circuits and devices lab. Now experiment is 2B, Norton's theorem. Okay, so experiment number 2B, to verify the Norton's theorem. What is the aim? To verify the Norton's theorem. This is apparatus required table. So resistors, RPS, voltmeter, ammeter, breadboard, multimeter and connecting wires. Based upon the circuit diagram, we have to design the apparatus. Okay. Next, this is the overall circuit diagram for Norton's theorem to find the IL. Right. So, to find the IL, first one. So here it is a this is the load current. So for the Norton's theorem, we can say it is the IN, there is a Norton's current. Okay, so this is the circuit. So we have to connect the circuits. First of all, here see R1, R2 and R3. All the resistors are 2.7 kilo ohm. Then RPS available 0 to 30 volt and 1 ammeter. Then RL is the load resistor. Here the 1 kilo ohm. Right, so this is the RPS, this is RPS, here having ammeter. Okay, now we have to connect the resistor. So see the first one, this is the 2.7. okay, red, violet and red. So I have inserted here first resistor R1. See, this is the R1. I have inserted here R1. Second, we have R2. So this is the connection. So R1 end we have to connect to the R2 first end. Okay, see here R1 second end we have to connect the R2 first end. See the circuit. Right, this is 2.7, this is also 2.7. So intersection of the R1, R2 we have to connect the R3. So this is the R3. See the circuit, right? So I have inserted here. So this is the normal resistor connection. Okay, resistor connections are finished. Now we have to apply the ammeter and RPS. See here, this symbol is long line is a plus and short line is a minus. This plus is connected to the first resistor end. This is RPS. I have to take RPS positive. So resistor first end I have to connect it here. Right. Then RPS negative. See here in the circuit, RPS negative is connected to the R3 end. This is R3. This is RPS negative. I have connected the R3 this end. Okay, R3 this end. That is RPS negative connected to the R3 end. Right. So now we move on to the ammeter. Right, here see R2, end of the R2 resistor have a RL. RL is 1 kilo ohm. So 1 kilo ohm resistor. 1 kilo ohm resistor, brown, black and red. See here brown, black and red. So I have connected R2, another end we have to connect the RL. RL 1 kilo ohm. Right, RL 1 kilo ohm. RL second end we have to connect the ammeter positive. RL second end we have to connect the positive. Right, I have connected. Now ammeter negative end we have to connect it to the R3. See, RL first end, RL second end have to connect the ammeter positive. Then ammeter negative connected to the R3 end. So R3 negative end. Okay, now I have to switch on the RPS, right? I have to put 15 volt. Okay, nearby 15 volts. See the ammeter reading. See the ammeter reading 15 volt. If I have put the value in voltage 15, I have get the result is 1.1 volt. From the tabulation itself, serial number 1, the input voltage 15 volt, then the load current IL. That is, we have to have a theoretical also 1.1 and the practical we have a value 1.1 milliampere. Next we have to calculate the RN value. That is the resistor value. Norton's resistance we have to calculate it. Alright. So this is the RN value. RN circuit diagram. See here. So I have to switch off the RPS. Then I have to remove all the ammeter and the RPS, then RL also, because here only having resistors, right? So only we have resistors only. So using the multimeter, we have to connect for the resistor value. So resistor value means there is no any current, no. So having parallelly connected. So at a time we have to move for the parallel connection of the 2.7. Alright, here also we have to put the 2.7. Parallelly we have connected for the 2.7. Then the intersection point we have a R3. There is no any voltage drop. There is no need about the RPS. We have to calculate only for the resistor value. This is the multimeter, right? So using the multimeter, we have to calculate the, right? See the reading. So we have to calculate the multimeter. See the reading 4, right? So 4 kilo ohm, right? So this is the resistor value is 4 kilo ohm. Rn equal to 4K. Tabulation itself we have a theoretical 4 and the practical 4 kilo ohm, right? Now we have a equivalent circuits. Norton's equivalent circuits. Here see the diagram. Here the RPS, then the ammeter 1, ammeter 2, then RN value is there. This is the RL load. This is the final equivalent circuit. RN value already we have calculated 4K. Then RL value already we know. From the circuit itself we know. So 1 kilo ohm. So here what about this voltage? So this voltage is nothing but that is whatever the value getting from the first IL value, we have to fix it. Here having already we have calculated practical value 1.1 means, so we have to fix the ammeter value 1.1. Based upon that 1.1, that the RPS value will be changed. Okay, now we see about the because here for the Norton's equivalent circuit, finally we have to calculate the IL dash value. That is the logic. Okay, right? So if for the verification procedure is IL equal to IL dash, right? So here having IL value here 1.1, right? So this 1.1 is matched to the IL dash. That is the calculation of the Norton's verification. Now I have to fix the 4 kilo ohm, right? See the circuit connection. So here I have to put the 4 kilo ohm, right? 4 kilo ohm. Here we are using 2 ammeters. right? First of all, we have to connect the RPS. Here see the diagram, RPS plus and minus is there. So I have to take the RPS plus. I have to place any one of the place in the breadboard, okay, because here having RPS positive is connected to the ammeter positive, first ammeter. So this is the ammeter, it's the ammeter positive, first ammeter, okay. So that positive is connected, okay. Are you clear? So RPS positive, this is the place, then ammeter, first ammeter positive connected, okay. Ammeter negative, take ammeter negative, it is the first end of the RN. RN is a 4 kilo ohm, first end of the RN, right? First end of the RN we have to place it here very easily. Okay, so ammeter negative is connected to the RN first end, RN second end is connected to the RPS negative. So RN second end, see RN second end is connected to the RPS negative. So I have inserted here, right? RN second end is connected to the RPS negative. Now I have to take the second ammeter. Now I have to take the second ammeter. See the circuit, RN first end is connected to the ammeter. So RN first end connected to the second ammeter positive, right? Positive. RN first end is connected to the ammeter positive. Ammeter negative connected to the RL. So I have to place any one of the place in the ammeter negative line, because we have to move for the RL. Okay, I have to take the RL, brown block, red, right? So that the RL end will be connected to the RN second end, okay. RN second end, okay. Now connection is finished. Now we have to switch on the RPS. Here I have to put the 1.1 milliamp, because that is the IL value, right? Then only RPS voltage will be changed. That is the verification procedure. So see the ammeter first. I have to switch on the RPS, okay. I have to reduce the ammeter value, bring to the 1.1 value, right? 1.1, because this is the I1. So based upon that, voltage will be changed. See the result here. The first ammeter I have to put IL, first IL value 1.1. Based upon that, RPS change. Here see the ammeter second value exactly 4. So this is the final result of the IN values, okay. Thank you, students. We see about the Nortons equivalent circuit. This is the circuit of Nortons equivalent. Now here having the value R and 4 kilo ohm, right? Using the 2 ammeters only, we have to calculate the IL dash, right? Now R and 4 kilo ohm, this is the 4 kilo ohm resistor. I have to insert it here, 4 kilo ohm, right? So I have inserted the 4 kilo ohm resistor. See here, RPS positive and ammeter, first ammeter positive are connected. So I have taken first ammeter positive, first RPS positive, then I have take first ammeter positive, both are connected. So this field is finished. Now we move to the ammeter negative. Ammeter negative is RN first end. First ammeter negative is connected to the RN first end, right? See, then RN second end is connected to the RPS negative. So RN second is connected to the RPS negative. First ammeter is finished. Okay, first ammeter is finished. We go for the second ammeter. I have taken here second ammeter, right? Then see the circuit. First ammeter positive connected to the first end of the RN. So this is the positive one. So I have connected the second ammeter positive connected to the first end of the RN. Then ammeter negative, second ammeter negative is connected to the RL. RL is a 1 kilo ohm, right? RL is 1 kilo ohm. Brown block and the red, right? So RL, brown block and red, it will be connected to the ammeter negative. Then first of all we have to place it ammeter negative in any one of the place in the breadboard. Okay, I have inserted here. Okay, ammeter negative. So ammeter negative, then RL first end is inserted. Okay, RL one end. RL second end is moved to the RN another end. Okay, RN negative end, right? So that's all about the connection. Right, now I have to switch on the RPS. So before that I have to explain here for the ammeter, I mean IL value is a 1.1, right? So we have to fix the first ammeter is a 1.1 based upon that RPS value will be changed. The same value is displayed in the second ammeter. This is IL dash, this is IL, this is IL dash. So we have to verify that. Okay, I have to fix. See here, this is the nearby. I have to put 1 point. This is the 1.1, right? Okay, see here the same 1.2. So just one change, 1.3 or 1.2. Okay, see here RPS value I have to put 0.1. Now IL equal to IL dash. See the same, just so this is a discrete now, so just a slight changes is there. So here 1.1, here for the 1.2, right? 1.2, that's all. So finally that is IL equal to 1.1, then IL dash equal to 1.2 milliampere. Hence Norton's theorem verified. Thank you, students.